Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, now we are going to do the second numerical which is based on ideal gas equation with different data. So let us do it. So as mentioned on your screen, there is a numerical which is based on ideal gas equation. So let us first observe what are they asking about. So they have written that we have to calculate the number of moles of hydrogen gas present in 0.5 dm cube sample of hydrogen gas at a pressure of 101.325 kilopascal. This K stands for again kilopascal, and at 27 degrees Celsius. So this is the question that they have given to us, and we have to calculate what will be the number of moles of the hydrogen gas present in this kind of condition. So the first thing that we are going to do is we are going to write the given data, so as it would be very much easy for us to write the numerical and to deduce that what would be the answer of it. So suppose, yes, in the given data, what is being provided, the thing which is being provided is basically the first one, that is volume. The volume is being provided as 0.5 dm cube, as well as they have also mentioned the pressure, that is P is equals to, that is 101.325 kilopascal. And the next is they have also presented the temperature as basically 27 degrees Celsius. So this is what they have given to us, but we have did a lecture on, that is gas constant and of its units. So it has different values depending on the units and depending on the condition, that how which kind of parameter that we take. So in this case, what we clearly observe is that they have given us something related, the pressure related to Pascal. So in this case, it has been presented in kilopascal, so we are going to convert it into Pascal itself. So therefore this would be basically 101.325 kilo means 10 raised to 3 Pascal. So therefore this can be written as 101.325 into 10 raised to 3 Newton per meter square, because Pascal is nothing but Newton per meter square. As well as if we observe that the volume which has been given as 0.5 dm cube, so this dm cube should be converted into cubic meter, because it has been related to meter itself. As you could see that Newton per meter square, this is related to meter, so we have to convert the volume from decimeter cube to cubic meter or meter cube. So therefore it would be very much easy to do this thing. So therefore 0.5 multiplied by 10 raised to minus 3 cubic meter. This is what we have did for the volume. And now talking about the temperature. So in this case, basically the temperature is being given in degree Celsius, so we have to convert in Kelvin. So what we are going to do is we'll add up 27 degrees Celsius with 273.15 Kelvin. So this will give me a 300.15 Kelvin. So this is the temperature that we have got, this is the pressure we have got, and this is the volume that we have. So if we include or if we have did all those value in the form where I could easily write the gas constant value as R is equals to basically 8.314 joules, yes, per mole per Kelvin, or joule per Kelvin per mole. So now I could easily make the value of R as this one. So suppose in this case, if we have made or we have extracted the data, and instead of R we have substituted any value that we have calculated, like 8.314 into 10 raised to 7 per Kelvin per mole. So it would have been a different scenario, or we can't even insert that is 0.082 liter per liter atmosphere per Kelvin per mole, because that condition is of different thing. That's the reason the value of R are different for different condition of different parameters that we take. But in this condition, what they have provided us is they have provided in Newton per meter square. They have given us the volume in cubic meter, as well as the temperature is presented in Kelvin. So now we could represent among those four, we have choose only the value of R as 8.314. So now it will be very much easy to calculate the answer or the requirement. So now what I'm going to do is I'll write the formula of the ideal gas equation. So therefore, basically, according to ideal gas equation, PV is equals to nRT, and in this case we have to calculate the value of n. That is, therefore, n is equals to basically PV divided by RT. So therefore, the value of P that we have calculated in this case, or we have converted into a unit, a proper unit, which was found to be basically 101.325 into 10 raised to 3, that is Newton per meter square. Okay, so now talking about the volume. The volume will have that we have calculated is 0.5 into 10 raised to minus 3 cubic meter. And talking about this thing also, I would write here so that it will be very much easy to understand that how can we do this kind of numerical. And talking about the next one, that is the value of R. What they have provided to us is the value of R is basically 8.314 in basically joules per mole per Kelvin. I'm writing in this way, and the temperature which was been provided, it was basically that is 300.15 Kelvin. So this is what they have provided to us, and the thing now, it would be very much easy to calculate, so I am calculating this thing. So the value that we have got is basically 0.2 moles. So this is the value of the number of moles of hydrogen that we have calculated, so by using this formula. So thank you friends for watching this video. I hope you have liked this video and you have understood that how could you solve this kind of numerical, yes, with proper value of the gas constant. So share this video with your friends, and yes, don't forget to subscribe Ekeeda channel. Thank you so much.